Math 1332, Chapter 3, Symbolic Logic, Section 2, Truth Tables. Video 6, Truth Table Example 1, 2 simple statements. The next 6 videos, including this one, are just going to be working out examples because, trust me, these take practice. And when I say practice, I don't mean just watching me do them. I mean you doing them. Sorry, some thought just ran through my mind. So we're going to start with some truth tables that only involve 2 simple statements. For this one, we're going to construct a truth table for the compound statement negation P, disjunction Q, or equivalently, negation P or Q, or even briefer, not P or Q. It's important to know your symbols for your connectives. We're going to take the same steps we took in the previous video, starting with step 1. That's not step 1. Starting with step 1, using the hierarchy of connectives, determine the order to address the connectives and negations. Step number 2, set up 1 column per simple statement and list every possible combination of their truth values. Step 3, next, label 1 column per negation/connective in the order previously determined. And then finally, from left to right, complete each column, asking the same 2 questions each time. What rule am I using? What previous columns am I applying that rule to? The most common mistake people make in completing truth tables is forgetting their rules and knowing which prior columns to refer to when they're populating a new column. So if you focus on those 2, you should be okay. All right, so we're going to start by determining the correct order in which to build the truth table for this compound statement. Let me make sure it's the correct one. Yes, it is. According to the hierarchy, where do we go first? Well, there are no parentheses, so we move to the next thing on the hierarchy, which is negation. So this negation will occur first. There's only 1 connective left, but the next thing on the hierarchy is conjunction/disjunction. And that will be the second and final column after the columns for our simple statements. Now remember, once you've decided the correct order, your first 2 columns are each individual letter that's already in the compound statement. So we're going to start by having 1 column for P, 1 column for Q. And by the way, they don't have to be in that order. You can put Q first and then P second, but let's just stick with alphabetical order at the beginning. And those truth values are true, 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 false, false, true, false, true, false, false, excuse me. Then set up 1 column per negation or connective based on the order that you have in the hierarchy. So since we had 2 symbols, a negation and a conjunction, we need 2 more columns. When you're drawing your columns, pay attention to the connective or negation that you're building them for, because that can help you dictate the width. For example, our first column after the simple statements columns is for the negation, which belongs to the P. So our first column only has to be wide enough to accommodate a negation P. So let's make that column about this wide. Doesn't have to be too terribly wide. And that will be the column for negation P. Excuse me. Negation P. The last column needs to be a little bit wider because the last column is for the conjunction, but this conjunction has negation P on the left and Q on the right, so it has to be wide enough for the entire compound statement. One piece of advice is to not draw a vertical line ending a column until you know how wide the column has to be. Obviously, I did not do that here. Oh, speaking of lines, there are some people that will not just draw vertical lines separating the columns, but will draw horizontal lines separating the rows. And there is absolutely nothing wrong with doing that. It just takes more time to draw those horizontal lines. But if it helps you stay organized, then by all means, go for it. All right, Now that we have the columns created, we just have to populate them from left to right. I invite you to pause the video and see if you can figure out the first column, which is not currently labeled, and that's about to be fixed, and the second column. Remember, I don't number the simple statements columns because they're just default part of the problem. But I invite you to pause the video and see if you can populate both columns. And remember, when you populate a column, you ask yourself two questions. What rule am I doing? And what previous column am I doing it to? All right, hopefully you paused the video and gave it a try. Here we go. First column, the negation P. Question, what does negation do? What is the rule for negation? Negation changes the truth value. So the rule that we're going to do is we are going to change the truth value. But which previous column are we going to look at? That's like asking, who is the negation on? The negation is on this P, which means we have to look at the column that represents P. That's the column that we want to focus on when we apply the rule. Notice that the Q column is in the way. I would recommend covering it up with your finger, with a pencil, with whatever, just so it's not obstructing your view and causing you to glance and put something wrong. All right, let's play out the rule. The rule is we're going to change the truth value of that previous column. And one thing that you can do to refer to a column is to draw an arrow back to that column, but then things get messy because you got arrows all over the place. It's easy for me because I can just delete them pretty easily. All right, so we're going to look at the first column, we're going to look at the P column, and we're going to change the truth values. The P column says true, true, false, false. So if we change those, we get false, false, true, true. That's a pretty easy one because negation is simple. Just change the truth value. All right, let's clean this up and then we'll look at the next column. All right, for the second column, you have to ask yourself what rule we're going to do and what we're going to do it to. The rule is dictated by the connective that the column was built around. The second column was built around the conjunction. So, that's a disjunction because disjunction points down, alliteration, disjunction, down. What is the rule for disjunction? You remember? Without looking it up? The rule for disjunction, you really need to know these rules. The rule for disjunction is false only when all F's. That's not the way it was written previously. The rule in more words said a disjunction is false only when all of its simple statements are false. But the shortest version of saying that is F only when all F's. Now, which prior columns are we looking at? Well, what's to the left of the disjunction? The negation P. And what's to the right? The Q. Which means we need to look at the negation P column and the Q column. And guess which column we don't need to look at? This one over here. Again, you don't have to cover the columns that you're not focusing on currently, but if you have trouble focusing because all the mess of columns and rows and trues and falses, then I would cover it up. All right, so we are looking at the Q column and the first column, and we're going to play the rule false only when all F's. Do you see any row that is all F's? Oops. The second row is all F's. The second row is the only row that follows that rule of all F's. So that is the only row where we write false. No other row has all F's, which means no other row is false. That means the rest of the rows are true. All right, let's clean this up. And we've completed the last column, thus completing the truth table. And remember what this truth table really means, because it's easy to lose sight of what's going on here because there's so much going on. This truth table says, I know whether this statement is true or false based on the truth values of its simple statements. When both simple statements are true, the compound statement is true. When P is true and Q is false, my compound statement is false. When P is false and Q is true, my compound statement is true. And when both P and Q are false, my compound statement is true. That's what this truth table means. Now, I want to wrap up this video with one question. Where have we seen this before? More specifically, which basic truth table has a final column that goes true, false, true, true? Where's the only false? When P is true and Q is false. And when did that happen? The conditional. Now, this is a side note, and you don't have to make these observations every time you complete a truth table. But I'm making this observation because it's something that we're going to follow up on in a future video. Notice that the last column for negation P disjunction Q is the same as the last column for the conditional P pointing to Q. This means that negation P disjunction Q and P pointing to Q are logically equivalent. There I go, using that phrase again without defining it. Later, I think it's in this series of videos. Let me see. No, it's in the next section. Later, we are going to expound on this, because what it does is it allows us to interpret a conditional as a disjunction, and vice versa. A disjunction is a conditional. Again, this is just a side observation. If the question was complete the truth table, it was finished the minute that we had all of this done. Good, that doesn't look good. All right, we'll do another example in the next video.